Good afternoon, everyone. This is Dr. Rostenberg again, coming to you from Beyond MTHFR, and I want to share with you today some science that's just so important that everyone, whether you're a researcher or a doctor or a parent or a college student or a young athlete, at any stage in your life, knowing about this information, it will be advantageous to you. It is all about how your brain functions and how your blood sugar and insulin levels influence how your brain is working. And so when I'm talking to patients all over the country and all over the world about how to balance their genetic pathways, COMT and MAO-A, one of the most important things we have to do is eliminate excess stress. Excess stress, guys. Life is stressful. Being a parent is stressful. Having a job, having a business, owning a house. Stress is a necessary part of life. But excess stress begins to become an injury to us, especially in people like me and many of you with COMT and MAO-A pathway uh, polymorphisms. Okay? So let's take another look here at the dopamine and serotonin um, scenarios here. Kind of get our refresh our memory about these two neurotransmitters. So serotonin, we'll talk about real quick. It's the sort of companion neurotransmitter to dopamine slash adrenaline slash epinephrine. Okay, so just adrenaline is what we call epinephrine in the United States, and the rest of the world it's called epinephrine, just like miles and kilometers. I'm just pointing that out. But dopamine and adrenaline um, are the catecholamines, and serotonin is a neurotransmitter that's not a catecholamine, but it's critical for us to feel good. So people who are depressed, chronically fatigued, low libido, lack of pleasure, apathy, not interested in exercising or having sex or eating good, doing anything that brings them pleasure, they don't have enough neurotransmitters in their brain to feel the pleasure, guys. And that's as we go forward through this video, you'll see a very simple, basic thing you can do every day to help improve that, and you'll see why also these neurotransmitters are low. You can read through this list and see some other things. Violence, aggression, those are also associated with low serotonin. High serotonin, on the other hand, in my opinion, not as common clinically or in the society, but it still happens. People who have really bad reactions to SSRIs, those powerful and dangerous psychological drugs. A lot of those patients are getting way too much serotonin. They'll be restless or very agitated, have episodes of sweating and rapid heartbeat, shaking, nauseous, vomiting. So those are symptoms of too much serotonin. But the real focus of today's video is going to be on dopamine. And dopamine is something I believe with a little bit of study and awareness on your part, you'll be able to just nail everybody in your life, yourself included, who has low dopamine at times. In other words, knowing what dopamine does and what low dopamine feels like, you'll be able to just figure out very quickly who has low dopamine and some things you can do to help them. So everybody who's addicted to something, and I'm not talking just about people who are doing heroin or addicted to gambling. I mean people who are addicted to eating oatmeal for breakfast and eating cookies and orange juice and you know uh, having the inability to control their diet with discipline. So that's an addictive pattern. All those addictions are designed to raise dopamine. It doesn't matter what you're addicted to, guys. I mean, everything that people get addicted to raises dopamine. It's our way to self-medicate. It's not a bad thing, okay? We're always going to have addictive behavior. I think that's human nature. Just choose your addictions very carefully, please. Go healthy and get addicted to that stuff, and you'll still get a dopamine burst when you make a wonderful vegetable-based organic food dinner. Um, you don't have to always eat the garbage food that everybody else does. Low dopamine also, of course, anger. So the person like me when I was younger, all the time, very angry on the soccer field, angry at school, angry socially, anger issues. Well, anger issues are low dopamine problems. So think about yourself, your family, your friends, your coworkers, the people around you who are always like a grumpy, frustrated toddler, whether they're actually a toddler or a grown up, it doesn't matter. Those individuals have low dopamine. Getting angry raises dopamine. Again, you're looking at people self-medicating. Their dopamine drops, their brain doesn't function as well as it could. They get angry, and then a little while later they feel like themselves again, kind of the Jekyll and Mr. Hyde effect. That's what low dopamine is. So low dopamine is addictions, cravings, and anger. High dopamine, kind of some scary stuff over here. People dealing with schizophrenia, aggression, anxiety, a lot of panic and anxiety out there. I deal with that every day in my practice, whether people coming in the office or we're working over the phone. You're looking at a phenotype, you're looking at a genetic expression of somebody with really high catecholamine levels, really high dopamine and stress hormones. And this video is all about how to prevent that, because one of the biggest influences on your brain's dopamine levels and adrenaline levels is your blood sugar. This is a report from Sterling's app, the 2.0. They've updated everything, got some more information for us. And these are the SNPs. These are the polymorphisms for the genes that we're going to talk about that are the most influential here today. The MAO-A system and the COMT system. And the reason these are red on the report is because they're in a slowed situation. So genetically, this individual is predispositioned to have slower clearance of dopamine and adrenaline. Now, you can see the pathway of getting rid of adrenaline, which I've written here as epinephrine. It's basically very similar with dopamine. I just didn't draw it for you today. So dopamine and epinephrine have basically the same amount of steps to take it from inside your brain to in the urine. So you're going to have many steps that are required, and the red arrows pointing down are showing you where genetically that process is slowed. So people with these COMT and MAO-A genes, like myself and many of you, you're just prone to having elevated levels of adrenaline. It's not always a curse, because you also are prone to having higher levels of dopamine, which when you're healthy you could be very creative and get a whole lot of stuff done and have a great memory and see the big picture, and just you're actually very gifted. Apples to apples comparison, you have more dopamine than other people. But if you don't balance your blood sugar and other things, you will have way too much dopamine, and you're going to be stressed out, anxious, panic, your sleep's going to get messed up, and your whole body's going to dysregulate. And that's the main idea that with this whole conversation on this video is how blood sugar influences this. So just a quick reminder too, that depression is not wanting to paint in the color blue and listen to loud heavy metal music all the time. That's not depression. Depression is simply a decrease in brain activity. A decrease in brain activity. That's all neurologically depression should be understood as. And this is an MRI just showing, functional MRI showing two different brains. This brain's depressed. There's not a lot of activated colors, yellow and reds. Over here you can see this person's not depressed. Boom, their brain is working as it should. It's fired up. And this person on the right has the balanced level of dopamine and adrenaline. This person on the left, they certainly do not. And even the peer-reviewed research says the same thing. Inflammation underpins the development of depression by removing serotonin and creating toxic byproducts. So inflammation creates depression, and inflammation is a giant influence on gut behavior. So I talk a lot about hypoglycemia, and I rule it out in every patient's case, because the odds are that somebody who comes in who isn't sleeping, has terrible digestion, acid reflux, leaky gut, or IBS, is depressed with low libido and low energy and can't lose weight, the odds are that they're hypoglycemic until proven otherwise, because hypoglycemia creates a lot of misery. It actually destroys white matter. I've shown this slide before. Hypoglycemia, in fact, it's neurotoxic. It actually damages your brain. But that's not the big problem with hypoglycemia, although that is one of them. The big problem with hypoglycemia is that when you spike your blood sugar, as this line is showing, and then your blood sugar drops quickly after, your body cannot keep up with that imbalance. So your adrenal glands are what work in the background with your pancreas to keep your blood sugar stable. So if your blood sugar goes up really high really fast and then it drops really quickly shortly thereafter, your body is not designed to balance that out. It doesn't work fast enough from the endocrine system's point of view to keep your blood sugar stable. And as your blood sugar is unstable, so is your insulin, and now you're going to see how that affects your neurotransmitters. I drew this. If you want to read it, just pause the screen and you can read each box here. But basically, the reason that blood sugar influences dopamine and adrenaline is that you cannot, I repeat, you cannot get the precursors and the amino acids that turn into dopamine or serotonin into your brain unless your blood sugar is balanced. So tyrosine, phenylalanine, tryptophan, you've all heard of these. They cannot get into the blood-brain barrier by themselves. They do not cross the blood-brain barrier by simple diffusion. They have to be escorted across, like on a ferry boat, and I'll show you a picture of this. So a ferry boat has to carry these amino acids across. So you eat chicken, you have some protein with your meal, your body, your stomach works to break it apart, your gallbladder, your pancreas, your small intestine, they all do their part, and you get some of that tyrosine into your bloodstream. Now that doesn't guarantee that you're going to make dopamine yet, because that tyrosine has to get into your brain, and then there has to be iron and vitamin C and other nutrients and methyl groups to help you produce that dopamine molecule. But that's for another video. But in other words, you're seeing here, you eat, you can't get tyrosine and phenylalanine across the blood-brain barrier. Insulin, however, makes it possible, because what insulin does is insulin makes room on this transporter for the precursors of dopamine to go into your brain. Said another way, the only way that tyrosine and phenylalanine are going to go into your brain and turn into a neurotransmitter that improves your focus, your learning, your memory, the only way that that's going to happen is if there's space on this amino acid transporter. And insulin influences that because insulin makes changes in the blood amino acids. And I'm getting a little technical here, so bear with me. When insulin is elevated after a meal, branched chain amino acids go out of the bloodstream into your muscles. Okay? If you have tyrosine in the bloodstream, phenylalanine and tryptophan after your meal, there'll be more room on the transporter to go into your brain. And I drew a picture of this, or used one that I think can illustrate it. So this ferry boat, the dark cars are amino acids other than tryptophan and tyrosine. They're branched chain amino acids. And the light colored cars are tyrosine, tryptophan, phenylalanine. Okay? Obviously, if you show up to the ferry boat to go across and there's too many dark cars filling up all these spaces, there's no room for tyrosine and tryptophan on this ferry boat. Okay? But if your blood sugar is balanced and you're taking care of your insulin by eating frequently throughout the day, then there's a lot more white cars on this ferry boat, okay? Because there's more room for tyrosine, more room for tryptophan, more room for phenylalanine to go across into your brain. So the idea with what I'm sharing with you is when your insulin is balanced, when you're eating frequently, when you prevent hypoglycemia, you allow your brain to be fueled with the precursors of dopamine, adrenaline, and serotonin all day long. And that changes people's moods. And that allows individuals with talent and potential to get closer to what they can do with their life. Because if people who are really smart, I've known them and I've been one of them, aren't balancing their blood sugar, they're going to have moments where they're on and they're focused and they're doing really well, but the rest of the time they're going to be like a total wreck because the brain is not getting a steady supply of the things it needs to focus and pay attention. So I'm going to share this with you again. I've shown this before. These are the symptoms of hypoglycemia. Daily headaches, especially in the afternoon. Very tired, especially in the afternoon. You may eat lunch and just fall asleep for an hour and then wake up. I mean, that might be normal for you, but that's not normal. Hunger, I used to, when I would go over to friends' houses, I would eat 2 or 3 times as much as everybody else. And it wasn't because I wasn't being fed at home. It's just after 5 or 6 hours of playing and having my blood sugar drop through the floor, I mean, my body was ravenously hungry. And it's not a good situation because you don't digest that food that well anyway, as you'll see. Getting dizzy when you move around, sweating, changes in mood. I mean, they're showing, two faces here, but I mean, we're talking like toddlers and children who go from being perfect angels to like, little tyrants. That's a blood sugar problem, guys, until proven otherwise. And the hypoglycemia is the biggest issue there. And again, you fix it by eating frequently. So here we have another chart from my medical physiology textbook. And the reason I bring this up is to show you that as your blood sugar drops from right to left, the amount of this other hormone goes up, this red line. And glucagon shuts off your stomach acid. So not only does hypoglycemia impact your brain through this pathway of influencing how much dopamine you have, not only does hypoglycemia make you have focus for 10 minutes or a little bit of time, and then having no focus and fatigue and anger and personality changes, and you're on this roller coaster. Not only does it do that, but it totally shuts off the production of stomach acid, which is why in my office and in my practice I probably have go through more bottles of hydrochloric acid and stomach acid digestion support than anything else. This is why digestion is where we start with every patient. We make sure that every single patient is digesting well. Because if you've been hypoglycemic for 15 years like me, then I've had 15 years of having my digestion shut off every time I go and eat a meal. So if you go 5 or 6 hours between meals and your stomach's been rumbling and you've had difficulty focusing and maybe you had a headache during that time, and you finally make room in your space and room in your life to sit down and eat, thank goodness. Well, what's going to happen is when you eat that food, it's not going to digest very well because your body's just been dealing with a situation with low energy, and it's not going to have the opportunity to invest that energy in making your gut work well because there's not enough to go around. It's going to have to choose what systems it invests in. And intelligently enough, it's going to keep your heart beating and your diaphragm moving and your parts of your brain and liver working so that you don't die. But it's not going to invest in making stomach acid. And the reason I'm just sharing this with you to know this is why people have acid reflux all the time. They're hypoglycemic. Their gut stops working. Their stomach acid shuts off. They are having acid reflux. They're going to the bathroom, having a bowel movement, and there's like salad and food in their stool. That's not normal. That means your body and your pancreas isn't breaking it down. So again, the leaky gut comes into play. It causes brain inflammation, which interferes with how we feel. And so I just want to wrap it up here, pointing out that, your dopamine levels in your brain are heavily, heavily influenced by your blood sugar. And you want to be right here in the middle. And the longer you stay in this sweet spot, the better you're going to feel. You're going to feel like you can do anything, and you're going to feel your best. The people around you will notice as well. And when your blood sugar goes really high after a meal, you make a lot of dopamine, you come over here, and then 30 or 45 minutes later, you're swinging back down over here into low dopamine. You're just going back and forth all day long. And it doesn't need to be that way. It's very stressful and hard on your body. So those of us with COMT genes and MAO-A genes who are dealing with anxiety and anger issues and behavior problems, I'm really encouraging you to follow the advice in this video to eat frequently. And I've shared with you the science and the background of why eating frequently influences the neurotransmitter levels in your brain. If you don't eat frequently, your insulin is not balanced. If your insulin is not balanced, you cannot get tyrosine and tryptophan and phenylalanine into your brain in a steady fashion, and the that becomes a giant hurdle for us for our well-being. So thank you. I won't take up any more of your time. Um, Thanks again for all your time and attention, and I really appreciate all the feedback I've been getting from all of you out there who have been benefiting from these videos, and we'll stay tuned. There's more to come shortly. Thank you.